Hi, pleased to meet you all, everyone. I can already see at least a few folks I recognize the names of in the chat. But to introduce myself, I am Nathan Van Schmidt. I am the Waterbird Science Director for San Francisco Bay Bird Observatory. I'm also director of a new program that we are calling our Resilient Landscapes program, which is more focused on landscape scale, ecological vulnerability and adaptation, particularly to climate change. Which is a bit of the scale that some of the things that I'll be talking about today will also touch on. Let me get my PowerPoint sharing. And can everyone see this?
Great.
Great. So today I'm going to be talking about serendipity and salt ponds. And we will be talking somewhat about salt ponds, but about a bit of a wider range of topics as well. I'm excited to be able to have the chance to talk to everyone and give a bit more of a general talk about ecology and conservation. And I'm going to try to keep it a little lighter on the science, but we will dig into some graphs and theory as well, because I just can't resist. I'm going to start zoomed out pretty far though, with this satellite map of California that you can see on the right here. Now, I guess I can't really ask questions, but I'll ask a rhetorical question, which is if anyone can notice anything wrong about this satellite map of California. And the answer that might jump out to you at the start is that there's a very large lake taking up most of the south end of California. There is no farmland, and there are no cities. And that is because this is a satellite map of California as it looked in 1851, before most of European settlement had happened. It was reconstructed recently. The Central Valley was full of mostly of wetlands. The giant lake that you see on the south end is one of the largest freshwater lakes in North America at the time, and has since been almost entirely drained, of course, and converted to agriculture. The lake is no longer present, and most of San Francisco Bay has been covered in urban sprawl, and as well has been dramatically transformed. All of that began, of course, with the discovery of gold in California and the gold rush in 1849, which is why we start with that 1851 map. The gold rush led to a remarkable transformation in almost all of California's ecosystems, including here in the Bay Area, where San Francisco served as the main port for a lot of the gold rush immigrants and a lot of the exportation. Because of its central place in the middle of that transformation, San Francisco estuary began changing dramatically and rapidly. And it was really one of the first parts of California, which has now seen so many transformations, to experience these dramatic changes. Many of the earliest changes happened further up in the estuary, in the Delta region, closer to Sacramento, where a lot of the area wetlands there were drained and converted into agriculture. That was extremely productive farmland. There are now significant issues with those areas as they're subsiding rapidly and sinking and increasing in risk of loss of that farmland to sea level rise. And further out in the Bay Area, we saw a lot of wetlands that were transitioned over into development, infilled to build on, or infilled with trash and then built on top of. And down in South San Francisco Bay, in particular, we saw a lot of wetlands which were drained and converted into salt production ponds. This was not an overnight process, as this map shows. Some of the earliest transitions happened immediately after the gold rush, while many of the later ones occurred in the early 1900s, including a lot of the transitions of salt ponds in South San Francisco Bay. The end result was a widespread loss of tidal marsh habitats. These are the marshes that occur primarily further out in the bay as compared to further up the estuary, where there's more strong influence of the tides, and they push in tides. At high tide, water floods them, and at low tide, water goes out, and there's more exposed mudflats. There are a number of specialist species which are adapted to these tidal marshes. In particular, ridge-raised rail, shown here, relatively large and conspicuous for rail species, as well as the California. This is a federally listed species, and at the state level, we have the listed California black rail, extremely difficult to see. Let's see if we can give this another shot and find this guy. Nope, that's just more pickleweed. One more time. Almost found him. There's a little peak. And there we go. This is probably the most secretive water bird in all of North America. It's very small. It runs in tracks through wetlands, and I'm sure many of you have tried and failed to see it. But they're readily detectable by sound. And I'll be touching a bit more on them later on in the talk as I did my dissertation on the California black rail. And lastly, also of interest to managers, though dubiously ornithological and of interest to this group, there is the salt marsh harvest mouse, another threatened species that is dependent on pickleweed. One species that you might not realize is as dependent on tidal marsh are humans. Tidal marshes are viewed as one of the best possible defenses that we can have against encroaching sea level rise and flood risk associated with that. With very large tracts of areas, particularly of the tidal marshes themselves and the communities directly adjacent to them, severely imperiled by sea level rise under climate change. As a result, there has been significant of both the desire to protect those specialist species that rely on these tidal marsh habitats, as well as to protect our communities that rely on tidal marsh habitats, many of whom are, because they're already in flood-prone areas, disadvantaged economically. There is been, over the past decades, a really significant push to restore tidal marsh habitats across the entire bay area. The North Bay has already experienced a lot of this work. They're a bit further along in the kind of restoration process. But here in the South Bay, this really just got started in earnest in the past about 2 decades ago. And this will both provide a really critical buffer against sea level rise and climate change impacts to these communities, as well as help restore and recover the populations of threatened species that are at risk in the future. In 2002, when the work in the South Bay began getting started, this is what the landscape looked like. It had been drained and converted largely into these salt production ponds, which were owned by Cargill Salt. The greener ponds are the less salty ponds, and the redder ponds are the more salty ponds, and the water basically just gets pumped through a very complex system of these ponds, which are cordoned off from the bay by these dirt levees and gets saltier and saltier as it goes and as it evaporates more and more, all the way until you get some of those very bright white ponds where the water level has dropped out almost entirely. In 2002, Fish and Wildlife Service bought this. Most of these ponds, they have left some in the Maori complex, that really red area, as well as some just north of there in the Newark Hills complex. And those are still managed as salt production ponds, as shown in this map. So South Bay Salt Pond Restoration Project overall, however, plans to restore most of them eventually to tidal marsh. Currently, as you can see, those red ones are the retained salt production ponds, and the light green ones that are visible in most of the area. Let me see if I can get a laser pointer here. Yes. Most of these light green ponds are currently being managed, not yet as tidal marsh restoration, but as managed wildlife ponds, where the main transition has been dropping the salinity down from these hyper-salty salt production ponds and managing them for various wildlife species. And that is the current state of the project. Breach efforts are still ongoing, though. For instance, Ravenswood just had a new pond breached right here this last winter and is currently in the process of converting back to a native tidal marsh habitat. However, there's some complications when it comes to restoring these wetlands. One major complication is that they are already part of the Pacific Flyway, which is one of the 4 main migratory bird pathways in the United States, with the California portion of the Pacific Flyway being divided into 2 main tracks. One is the Central Valley here, and then another coastal track that moves through San Francisco. Every year, there are over 1 million waterbirds that use the San Francisco Bay either as migratory habitat during spring, fall, or both migrations, or as overwintering habitat. And many of those waterbirds are in the salt ponds. The record Christmas bird count, I believe, in terms of absolute abundance of birds, was found in Don Edwards National Wildlife Refuge down in the Salt Pond Restoration Complex. So these are hugely important habitats for waterbirds already, even before tidal marsh restoration, which begs the question of what the impact of these really dramatic transformations as we restore tidal marsh are going to be on the ecosystem. And there are a lot of different birds that use them. This is a list of all of the foraging guilds that SFBBO currently is tracking the abundance of throughout the salt pond restoration project. We look at small shorebirds, peeps like dunlin, leaf sandpiper, medium shorebirds, all the way up to the biggest or long-billed curlew, but also godwits, etc. Herons and egrets, fish eaters, pelicans, diving ducks, dabbling ducks, terns, gulls, phalaropes, a rather unique and often underappreciated saline specialist, of which there are only 3 species, and eared grebes, which are also a rather unique saline specialist species of diving duck. SFBBO and USGS have been going out since 2003, when the project was just getting started, and counting all of the waterbirds on each pond between 2 to 3 times each season. This involves going out with a scope, sitting down and driving around the levees and counting every single bird out there. There are mornings when I've been out there and have counted 4,000 ruddy ducks before 8 a.m. It is, in many respects, a dream come true, and in many respects, a bit of a stress dream where, my job somehow became to count every single duck on San Francisco Bay, or at least the southern half. It is a lot of birds and some pretty exhausting and intensive field work at times, but our biologists have been doing it for decades now without too much complaint. These are conducted year-round, except for summer surveys, because there are fewer birds, since most of this is migratory and overwintering habitat are now exclusively targeted towards a few species. And we then analyze that data based on each of the different guilds' main season. So for instance, if we're looking at ducks mostly use it as overwintering habitat, so we focus on analyzing their abundance over the winter. And I'm going to go through a few of our findings now from these 2 decades of monitoring that we've been doing. For duck trends, the overwintering ducks are looking pretty good, especially early on in the project. Dabbling ducks, when we saw from 2003 to 2006, The initial project management plan involved taking in all of the ponds that had been used for salt production and transitioning them from salt production to a less salty managed wildlife pond habitat. So that was the initial action that happened just in these first few years. You can see this salt pond restoration project is in blue here, while the other the ponds that have remained in salt production are in green here. And you can see that for dabbling ducks in particular, the abundance of birds as this transition happened absolutely skyrocketed, exclusively in the restoration project ponds. We also saw a slight increase immediately in diving ducks over the winter, with much of that increase attributable to ruddy ducks, but then especially a bigger increase over the past decade or so in the second decade of the project. We can see similar trends that look pretty optimistic, though not quite as dramatic as the ducks. If we look at medium shorebirds and small shorebirds, so these are things like our godwits and curlews again, black-necked stilts, as well as for small shorebirds, our sandpipers, our dunlin, etc. With medium shorebirds in the winter increasing fairly consistently for the first decade or so of the project, and then leveling off, and maybe in recent years showing a slight decline. And small shorebirds also, especially in their fall migration, increasing dramatically about a decade into the project, and they've been pretty steady since then. We do see a bit of up and down with these trends, which is pretty much to be expected. Most bird populations, if you observe them over long time periods due to climatic cycles, things like El Nino, show long-term trends that go up and down and up and down. And at least some degree of these changes are probably attributable to that as well. But overall, the project appears to have really helped these different migratory and overwintering gills. We also have 4 key species of breeding medium shorebirds and terns that USGS has been studying for several years, which have also been found to strongly prefer managed ponds and non-tidal marsh. These are American avocet, black-necked stilts, Forster's terns, and Caspian terns here. And you can see that the managed pond habitats, the salt ponds, the traditional salt ponds, are in the center here. And the 2 restored type of managed non-tidal wetlands are on the left here, with the managed ponds having by far the greatest abundance of many of the species, and the non-tidal marsh having greater abundance of especially black-neck stilts for both breeding, roosting, and feeding. However, there is a catch here, which is that if you look at the tidal marsh and the tidal mudflat habitat categories here, we see that these are used less than we would expect based on their availability. These are underutilized and not selected for by these breeding water birds. And that might be, in the long term, a problem. Because, as I mentioned, most of what's happened in the salt pond restoration project so far has been moving ponds out of salt production into a less salty, but still pond habitat. And that's a habitat that's big open water, which makes big open water fairly shallow, the sort of habitat that it makes sense that something like a dabbling duck might really like to sit in and forage in during its migration. But eventually, those ponds will be breached. You can see on the top here, it's a pretty simple process once the preparations have been made of just having a construction vehicle carve a hole in the levee, opening into the bay. And then over time, sediment is deposited in the pond, vegetation begins to regrow, more pond accumulates and is deposited, and the pond transitions from this open water habitat to a closed pickleweed tidal marsh. Again, great for salt marsh harvest mice and rails, but maybe not so good for other birds that want that open water. So not only that, there are even more complications, very cute complications, like the western snowy plover, which is also a listed threatened species that occurs within the Salt Pond Restoration Project footprint. They don't want the open water, which is the even bigger complication. They prefer the ponds as dry as possible. They, in particular, like the habitat when the ponds are in that really dried out state, where rather than forming a salt pond, it's a salt pan, and you have this open mud flat that's dry and salty. And as you can see here, their eggs are camouflaged very well, and the birds in this habitat are also camouflaged very well. As a result, there's also significant management interest in restoration actions, trying to make sure that as the restoration project proceeds, snowy plovers are not negatively impacted. One way that they've tried to do that so far is by oyster shell enhancement, which involves just getting huge boatloads of oyster shells and scattering them across the pond to confuse predators, which are one of the main ways that nests to fail. The predators are responsible for roughly half of nest failures, with corvids a particularly voracious group. And these oyster shells just help the birds get camouflaged very well. And so far, oyster shell enhancement has appeared to benefit the overall breeding population trends. It's hard to directly assign causation, but over the course of the project and with especially in recent years, we have seen general trend toward increasing snowy plover breeding populations, up from just over 100 previously to around 350 breeding birds this past year, which still has not reached, but is getting close to the SFBay recovery goal of 500 breeding birds. Snowy plovers aren't the only ones that like that kind of habitat. We also have the least tern, another threatened species, which breeds throughout the Bay Area. We already talked about this a bit in the intro, but they are found all the way up to Montezuma wetlands and Cullinan Ranch in the estuary, all the way down to Alameda Naval Air Station, Hayward Shoreline, and Eden Landing, finally within the restoration project footprint, which are fairly new colonizations. Within the Salt Pond Restoration Project, as I said, that's a relatively new colonization because these terns over summer were extirpated or basically absent from the project for a few years there. They declined rather precipitously shortly after the start of the project within the salt pond footprint, and had been persisting pretty much exclusively in the late 2000s within the remaining salt production ponds, and have pretty much continuously since the time when the ponds were moved out of salt production, done better in these salt production pond areas and had higher abundances there than within the actual restoration project. And all of that is because they prefer this anthropogenic habitat, this non-natural habitat, which is this dried out salt pan that historically wouldn't have been here at all. Back in the day, if you were looking down at the South Bay region, you would have seen something that looks somewhat like this, where it's a number of channels moving through a landscape, but rather than being in between dried out salt flats, it would have been in between flooded pickleweed marsh. And I think when we wonder how to manage that and what we should do about it, we do need to conserve them, of course. But I think the context here is really important as well. The snowy plover habitat within San Francisco Bay is rather unusual, that they're nesting really on in the salt ponds, as well as the open mud flats on the levees that divide up and divide those salt ponds, is not their usual habitat. Over most of their range on the Pacific coast, they're a coastal bird. They live in dune-backed sandy beaches, on river bars, and on a few salt pans where those do occur. And we see the same thing with least terns, where they're largely along the coast in sandy beaches and lagoons, but in San Francisco Bay, they choose to nest on constructed islands. Many of the ponds have had islands constructed on them to encourage greater nesting densities of water birds, partially to make up for the fact that the number of ponds overall are shrinking. So the idea is to construct more islands to make better habitat over a smaller area, as some is lost to tidal marsh restoration, but also on old runways where, such as in Alameda, where the birds are nesting as well. And this is very strange that we have all of two of these threatened species, listed threatened species, which are found locally entirely in anthropogenic kind of waste habitats. And one of the reasons that they're threatened more broadly is because the habitats that they should be in naturally are no longer very natural either. They're severely disturbed. We see snowy plovers, for instance, are threatened by widespread use of beaches as part of tourism, disturbance from dogs, such as this small fluffy white monster in the bottom left, drones, recreation, invasive species, such as ice plant shown here in the upper right, as well as general habitat loss to development, such as Santa Cruz Boardwalk down in the bottom right. As a result of all of that, we see that birds are no longer using a lot of what would be their normal natural habitat, and instead have come to rely on these anthropogenic habitats that exist within South San Francisco Bay. We're going to put a pin in that as we think about all of the other water birds that rely on these habitats as well. In particular, I want to shift gears for a moment to talk about some of those other water birds. In particular, looking at the saline specialists that exist within the South Bay Restoration Project. There are 3 saline specialists with the initial management plan, which foresaw that these might be particularly at risk of declines due to the fact that they specialize in very hypersaline ecosystems like salt ponds, were called out in the adaptive management plan very early on as needing special attention to make sure that they didn't decline. And the restoration project set up a number of thresholds to monitor, which are what's shown in the dashed line here. That's the threshold under which a decline is considered kind of significant, and at which point the restoration project wants to start investigating and try and figure out whether their actions have caused the decline, and if so, figure out a plan for getting the numbers recovered up above that level. And if we look at these 3 saline specialists, which are phalaropes, Bonaparte's gulls, and eared grebes, we see some worrying trends. All of these species are largely found in the saline lakes of the Great Basin, things like Mono Lake, Great Salt Lake, and all of these species have some trends that I think are cause for concern within the salt ponds. Phalaropes in particular have declined almost immediately beyond this kind of trigger threshold that was set. They've declined more than 50%. Bonaparte's gulls are also down more than 50% just in recent years. And eared grebes, although they have done reasonably well overall in the Bay Area, or in the South Bay in particular, most of those numbers are within the salt production ponds shown in green here. And in recent years, within the restoration project ponds, they've dropped to nearly absent as well. So I'm going to focus mostly on phalaropes here, because this is the species which has declined the most severely and most rapidly after the restoration project began. If we expand the scale on that graph there, this is a bit more obvious, where you see a decline from counts of over 12,000 birds early on in the project, before the ponds were transitioned out of salt production, to now about 1,000-ish birds, 1,000 to 2,000 birds overall in most years is what we're counting now. So it's more than 50% decline. And the big question here is whether that decline was caused by restoration project management actions. There's a picture there. Actually, I'll jump back here. In case you aren't familiar with phalaropes, I do want to highlight these fantastic birds. They are very unusual and unique. They swim in tight circles. They're shorebirds, about the size of a sandpiper. But unlike the sandpipers, rather than walking, they swim in tight circles and forage by basically kicking water out in a circle. And that creates a vacuum that pulls water up from underneath and pulls invertebrates up from the floor. And then they pick those invertebrates out of the water. So you can just see them just spinning and spinning in circles, foraging. In addition to that, they are hypersaline specialists migrating from the boreal areas of Canada all the way down to Argentina, where they use both Great Salt Lake, Mono Lake, SF Bay as migratory stopovers, but then also overwinter in salt lakes down in Argentina. And lastly, they're very interesting in that they have reverse sexual dimorphism. The males are smaller, and the females are larger and more colorful, and the males do almost all of the parental care as well. They're quite unique and interesting shorebirds, which is another reason to be concerned, I think, by their decline within San Francisco Bay. However, if we investigate what's been going on and what drove changes in those phalarope counts between 2003 to 2018, we can see some very confounding patterns. As I've mentioned, these are saline specialists, so we would expect that as salinity declined, the birds also declined. And what this graph shows us here is that the opposite relationship actually happened. As salinity declined, things that are on the left-hand side of the bar are an inverse relationship. So as that measure declines, the birds increased, or as the measure increased, the birds declined. And things on the right-hand side are a positive or direct relationship. So those the bird decline and the habitat change moved in, or the bird population change and the habitat change move in tandem. What this is showing is that as salinity declined, it's a reverse relationship. So the birds actually increased at a pond level, so that the overall decrease didn't correlate with the changes in individual ponds. So the ponds that declined the most in salinity saw increases in bird abundance, even as the birds were declining across the entire project, which was a very strange result that we did not expect to see. And when we go out today and survey for phalaropes within the ponds, we're seeing that the birds are actually using the low to medium salinity ponds and not the high salinity salt ponds that we would expect. So this is a very open area of investigation. We're out there doing field work right now, actually. trying to figure out why this is happening. But we have a few ideas. And again, here we're going to need to zoom out a bit. San Francisco Bay, if we look at Wilson's Phalarope, which is the one we have the better data for, in 1986, there were around 40,000 birds in San Francisco Bay. And that is part of a larger network of migratory stopovers along salt lakes throughout the Intermountain West, with the biggest population being in Great Salt Lake, but also another population around 40,000 at Mono Lake here in California. Wilson's Phalaropes in 2023 are down to around 1,000 birds. So between 1986 and 2023, we saw a 98% decline in this species. And we didn't see 40,000 birds when we started the salt pond restoration project. The counts then were again around 14,000. So these numbers don't all add up. And there's a question of how much the local declines and changes that we see are the result of restoration project actions versus actions across, or versus things that are happening elsewhere in the range. Because we didn't have any scientific surveys of phalaropes in SF Bay from 1986 to 2003, we decided to look at eBird data to see if the decline predated the restoration project. So this involved actually a lot of data that was from before the founding of eBird, historical data sets and historical checklists that folks had put onto eBird. So yes, if you have ever taken the time to upload your very old checklists into eBird, I thank you. The data does get used. It's very useful, actually, and informed this sort of analysis. When we look at the long-term historical data, we can see that there is a lot of variability in counts from year to year, first and foremost. This is really interesting because that there's this much variability where the monthly count per checklist basically varies all the way up from thousands of birds to just dozens. And there's really high variability, or there's some moderately high counts up to the 1990s and some really high counts back in the 1970s and 1980s. And if we transform this from a linear axis to a log transformed axis, we can see that there is still a pretty general decline overall that's fairly consistent all the way back from the 1980s to today. However, we do see also that if we compare to Mono Lake, which is the rest of California in red here, to San Francisco Bay, the annual trend line is much steeper for San Francisco Bay, but also the steepest decline occurred prior to the 2000s and the start of the restoration project. So again, what's going on here? Why did these birds decline so severely? Well, unfortunately, California isn't the only place undergoing a big transformation. And the bird, as bellwethers of saline lakes, phalaropes are affected by everything else that's happening to saline lakes, which generally isn't good. These ecosystems are in danger of collapse worldwide. Several of them already have. This is a picture of the Great Salt Lake, their main migratory stopover. Most recently in December 2022, right before there was a frankly miraculous rainfall event, Great Salt Lake almost reached a point in drying out at which the invertebrate populations that support the phalaropes would have, this water would have gotten so salty as the water evaporated off that it would have caused the invertebrate populations to collapse, potentially causing massive ramifications for the bird populations that were dependent on them, which also involve bearded grebes and the other saline lake specialist species like Bonaparte's gulls too. Great Salt Lake is not unique in this. This is Lake Abert, also in the Great Basin, which dried out almost entirely in recent years and has since flashed back on and become flooded again. And when that happened, we saw that the phalaropes again suddenly moved in. So there is an ability to recover local populations if the habitats flood again, but it's still a big disturbance to the ecosystem. And where this disturbance is coming from is not a big mystery. If you look just left of Lake Ebert, you can see that there has been widespread unsustainable diversion of irrigation water for agriculture, which is one of the main threats to these saline lake ecosystems. These water withdrawals are largely unregulated, and this is the reason that Great Salt Lake has dried significantly as well, and many others. Mono Lake itself would be far more imperiled than it is, if not for the fact that court order is protecting it. But even a large amount of its water is diverted down to Los Angeles. And this is not, again, localized even to the United States. If you look at the Aral Sea in West Asia, it has also pretty much collapsed as an ecosystem due to these unsustainable water withdrawals. And all of this is going to become worse under climate change. These diversions have weakened an already fragile ecosystem to the point of collapse. And if we add climate change on top of that and projected drier and hotter and especially more variable precipitation, there's a real risk that we could see widespread collapse of multiple saline lakes at the same time, which would be catastrophic for these specialist birds. So let's zoom back out again to California overall and think about these transformations that we're looking at. You can even see in this map, here's Mono Lake down here, Salt Lakes within the rest of the Great Basin out here. And the connections between all of these ecosystems, the birds migrate in the Pacific Flyway across a very large landscape, and they can shift which habitats they're using depending on what the conditions are in areas in any given year. We don't know exactly what the impacts of those shifts are, if there are increased mortality that's associated with those. Those are really pressing and unknown questions. But we do know that they can shift from year to year even what they're using. But we can also see that there's been widespread shifts in how they're using habitats overall. The great wetlands that are filling the Central Valley 150 years ago are completely gone now. They've been dramatically transformed to a degree where there's less than 10% left. So I shouldn't say completely, but almost entirely gone now. And by and large, we see a pattern across California where birds are reliant on these anthropogenic habitats. Let's touch on that again with a bit of a different example for a moment and go back to the gold rush. I promised that I would touch on black rails, and we're going to get back to black rails here. As we've been managing the South Bay Salt Pond Restoration Project for black rail habitat, we also have been we've been doing that, yes, for black rail habitat. But at the same time, black rails have colonized a rather unlikely part of California, the Gold Country region of the Sierra Nevada foothills. This is around Yuba and Butte counties, going up into the Grass Valley area. And you can see from this image that I took just after sunrise one morning while out doing my field surveys that the landscape is naturally very golden. Those are European grasses that have invaded, but otherwise it is very dry and semi-arid naturally. But this was taken in a wildlife refuge. If you go outside the wildlife refuges, it looks something more like this today. There are cattle everywhere, and you can see at the top of the screen here an irrigation ditch, which is running here. It's dumping water out, which creates pasture to feed the cattle. And where that water pools from that pasture, it creates a little cattail-filled wetland right here in the front. In that cattail-filled wetland, we find a unusual bird, the California black rail, which was not expected to be there. This is a state-threatened bird. This specific subspecies is state-threatened. The eastern subspecies is federally listed as well. And it was discovered by Jerry Pecklin, a researcher back in the early 90s. Jerry Pecklin published this report of the discovery of this breeding population of black rails in Yuba County when he first found them, immediately after, which was originally found in this site, Slicks Canyon, which was outside the Sierra Foothill Research and Extension Center. I will read this off briefly. We began monthly bird counts along Slicks Canyon in May 1994 as part of a project to restore riparian vegetation along the creek. Beginning an hour after sunrise, 1 or 2 observers spent 1 hour walking 600 meters up the creek, etc., recording all birds detected. And initially, we detected one black rail by its Kiki Kur call on 1st of June 1994. After they discovered it in this little canyon while restoring it for riparian vegetation, they began scanning all over across the foothills and found that the birds were everywhere. However, the foothills population itself had not really been documented. These wetlands were small. They had not been mapped or accounted for historically. They were kind of invisible because there were these rangeland accidental wetlands. So for my dissertation, I went out and mapped every wetland with satellite imagery. I conducted field visits to tons of them, hundreds of them, surveyed the landscape, talked with landowners, and in combination with historical aerial photos where we could trace the wetlands back through time and see how many of them existed historically back through 1947, and our talks with landowners, we determined the wetlands' water sources. This is the extent of the region that we covered. So again, from air, looks quite dry, but if you map out the wetlands, you find that they are covering the entire landscape in tiny little patchworks, with over 1,500 wetlands totaling nearly 1,600 acres. When we looked at the water sources, we found that nearly all of them received irrigation water in some way. Only 15% of them were wholly natural. 25% of them had both water sources, and 2/3 were solely fed by irrigation water. Which means that the wetland habitats in the foothills increased somewhere between 3 to 8 times their historic levels. Very large increase. 85% of all modern wetlands in Gold Country receive irrigation water, with 2/3 completely dependent on it. And most importantly, I think 83% of those modern wetland foothills receive irrigation wastewater. This isn't intentional irrigation. It's a mix of over-irrigation, runoff, and leaks. But it's supporting these native bird populations, which is a pattern that's remarkably similar to what's happening in the salt ponds right here in San Francisco Bay for the exact species that we're trying to restore the salt ponds to a native format to help protect. What do those habitat changes actually mean for black rails, though? Are they good habitat? Are they as good as the natural wetlands? Well, we have done long-term monitoring of this black rail population for a long time. We have seen a worrying decline in this population as well, largely which seems to correspond to the arrival of West Nile virus. In 2007, it arrived, and the key thing here is the green. This is our population estimate, our occupancy estimate. We can see it really plummeted after that, and we can see the rate of local extinction within individual wetlands. So wetlands becoming unoccupied sees periodic spikes after that happens. There's one big spike in 2007, but then there's several other periodic spikes that happen after that. By pure serendipity, again, happened to be doing my dissertation during this period when extinction was remarkably high, and which correlated with the historic California drought that hit in 2014. So the question is, are irrigated wetlands as good habitat as natural wetlands? And if we broke out the occupancy for an average wetland by water source, we found actually that they were better habitat than natural wetlands. Indeed, based on just our raw field surveys, by the end of the drought, no black rails were found in the wholly natural wetlands. They were only found in the irrigated wetlands that received at least some irrigation water, and the wetlands that received both natural and irrigated water were the best habitat. Why do we see that pattern? What is it about irrigation water that's so useful? Well, this is a little bit of a complicated graph, but let's walk through it color by color. We'll start with the blue one. And we can see here the time of the season, so it's time on the x-axis, and the percent of the wetland that is saturated. So it's how wet it is on the y-axis. And if we look at the natural wetlands, we can see that during the rainy season, so that's the early, can't actually see my own screen here, the early wet season and particularly the wet periods when it was rainy during the drought, we see that these wetlands become very saturated. They pop up and then they dry out immediately during the summer. They pop up and they dry out during the summer. And we see that pattern again and again. Because irrigation water is applied during the summer, the irrigated wetlands had the opposite pattern. They were dry during the wet season primarily, and then tended to be wetter during the dry season when the irrigation water was turned on. And we see that pattern as well. And that means that the wetlands that received both water sources were wet year-round. They received natural water in the winter, and they received irrigation water in the summer, and they stayed good habitat year-round, so the birds were not extirpated from the wetlands during the drought. In ecology, we have a concept called, which is often used to promote the conservation of species and biodiversity, called the portfolio effect, which says that if you have, 10 species of grass in a meadow, and you want to produce a lot of forage, you should have a diversity of species of grass, because some might respond better to flood, some might respond better to drought. And diversity increases the resilience of the system overall to disturbances like a drought, like wildfire, anything else that could harm the system's functioning. What I think that this graph shows is that maybe we should have a bit of a broader conception of diversity, not just of ecological processes, but also of human processes, of anthropogenic processes, where adding in this different type of water flow into the system, this flow in hydrologic diversity, just like different plant species might stabilize a natural system, this stabilizes the hydrological system and allows the birds to persist during drought. And if we think about it from a policy perspective, not taking this into account could really detrimentally impact the wastewater that feeds our natural ecosystems. In 2014, when I was doing this study, there was a drought state of emergency declared, irrigation runoff was banned, winter water was cut back, summer cutbacks were nearly implemented, and there was a big drive to increase efficiency and fix leaks throughout the system. In that tunnel vision towards efficiency of water use, you actually risk driving these species that depend on these inefficiencies and these accidental habitats that we create to be extirpated from the system and from the landscape. And we saw that if we ran population viability models. This is a series of projections that we ran based on our data with both wetland promotion and water cutback policies. And we found that creating irrigation creation policies, giving people free water to make wetlands, could nearly double the average minimum metapopulation size, so reducing the extinction risk by half. But if you had those water cutbacks in there, and the water was cut back and removed during a drought due to these conservation programs and desire for just water efficiency, all of that benefit was removed, and a significant number of our simulations led to extirpation for the species. And then I'll conclude this little section by talking for a moment about the outcome for this one wetland where the birds were originally found, which is that, as I mentioned, they found the birds in Slicks Canyon trying to do surveys to create a baseline for riparian restoration. And they went in and planted a bunch of trees, willows, in the area to try and encourage a willow flycatcher to nest in there. And as a result, the willows took over the wetland. It no longer became an emergent wetland. And unfortunately, the black rails aren't really found in this wetland anymore, but they are elsewhere nearby. And I don't think this is unique to California even. The very first project that I ever worked on was whooping cranes. This was my first field job. Whooping cranes are one of the most beautiful, majestic birds in all of North America, the tallest bird in North America. And they were at one point down to just, I think, 16 individuals that migrated between a single flock from Wood Buffalo National Park in Canada down to Aransas National Wildlife Refuge on the Texas coast. The whooping crane, they made an intensive captive breeding program. They managed to bolster up those numbers and recover them to hundreds of individuals in this flock, but they were still very concerned about it and decided to add that they wanted a second migratory population so that if a hurricane hit Texas, it didn't take out the whole species. So this was a really challenging thing to do, though, because birds learn their migration routes. So to do this, they decided they wanted to put a population that migrated between Wisconsin and Florida. And they had to do a lot of work for that. They had to dress up in crane costumes and hand feed the birds in captive breeding pens in crane costumes so that they didn't imprint on humans and knew how to mate correctly and do that. They had to live with them as they grew up in the wetlands of rural Wisconsin, teaching them how to dance and how to do their mating displays and all of these things. They had to actually get still in a crane costume in a ultralight aircraft and physically teach them the migration route down to Florida, stopping with them overnight in wetlands and camping, and over the course of weeks, flying the birds down to teach them this. This was a massive project that involved, I think, over $1 million per crane to do this. And when they finished all of that, the birds had finally learned the migration routes and settled down and were ready to reproduce, and they mated and they laid their eggs and they sat on their nest, and then they up and walked away from their nest. This was a major problem. The birds were not breeding. They were just not staying in the wetlands where they had been placed. And my first project was trying to figure out why this was happening. It's a complicated story, why it's happening. But one piece of it is that the birds were up and leaving and walking to cornfields next door because they were full of corn and they wanted to forage on the waste corn after the harvest happened. And again, I think this is just another example where you see water birds don't confine themselves to a natural wetland. The natural wetlands have been so dramatically transformed at this point that they over and over again are using these anthropogenic habitats, which are offering something that they need and which have already replaced, in many cases, the natural ecosystem. And in California, that's certainly true. The biggest thing on this entire map is the Central Valley. And all of that natural wetland has been transformed into various kinds of agriculture, rice agriculture, corn, and as well as some natural wetlands that are still remaining. And we can see that the birds use all of those. And then particularly the populations and birds dispersal, their use of San Francisco versus the Central Valley depends on when and where water comes in and how they respond to it. My concern when we're thinking about how to manage the South Bay salt ponds, they certainly need to be restored. Salt marsh harvest mouse and black rails and ridgeways rails all need habitat, and we need to protect the communities of South Bay. But also, I think about the black rails in the California foothills and how they need that water diversity. They need the diversity of wetlands that dry out differentially and respond to different habitat pressures and disturbances. Sea level rise and flood risk might imperil the wetlands of South Bay, but the wetlands of the Central Valley that are also part of the Pacific Flyway are imperiled by drought, especially under climate change. And we already have seen, like the citation I have here, that depending on if it's a drought year or a very wet year, the birds of the Pacific Flyway move around and need different wetlands. And the phalaropes, I think, if we go back to those really big spike years that we've seen, I suspect are years where the conditions were poor elsewhere in California. And that's where you see 40,000 birds coming into San Francisco Bay. And it's that resilience that's offered to the landscape and region overall that is created for the entire Pacific Flyway that I think is probably really crucial to making sure that as we experience a century of unprecedented climate change on top of ongoing land use change and development, that the birds can adapt. There's a really good article in the National Geographic about the salt pond restoration project called How the Bay Area is Restoring Nature's Delicate Balance. But if I had one criticism of this article, it's that we should be moving beyond the balance of nature. To some degree, this South Bay is never going to look like it used to, where it's just these natural flux of sloughs with tidal wetland dividing them up. And there's an article instead called Reworking the Conservation Geographies, Non-Equilibrium Landscapes, and Nature-Society Hybrids. It's a very academic article, but it starts, emphasis on flux is a major marker of the idea of nature at the millennium. Contributed especially by ecological science, the emphasis on flux is supported by convincing findings on biophysical processes, dynamic and stochastic ecological models, and theoretical and methodological examinations of ecology, biogeography, evolution, and diverse human uses of the land and other resources. Accordingly, the current understanding of ecological landscapes is claimed to be a new ecology, paradigm shift, which is a contrast to nature in equilibrium, and instead focusing on nature as embedded in human processes and evolving and continuously and flowing on. And I think that really this is how, as we're thinking about conservation in the Anthropocene and how to manage this landscape, this is some of the way we should approach this, is looking to manage nature's flux over a very wide area and how we can understand San Francisco Bay as a really crucial part of that. With that, I'm going to wrap up. I think I might be a little over here, but thank you for bearing with me, everybody. And I want to call attention to one last thing here, which is these birds using the Central Valley for cornfields, and some really wonderful work going on with Nature Conservancy in Point Blue to flood farm fields in the winter to both recharge aquifers and provide waterbird foraging habitats. As I think an excellent example of how we can manage water and water birds in California together with anthropogenic landscapes. Thank you.
Thank you so much, Nathan. Tony Brake had a question, and thank you for putting it in the chat, Tony. I saw you raised your hand. Have you looked at the effect of flooding on Owens Lake to mitigate the alkali dust storms that began around 2001 that's attracted hypersaline species?
I have not myself. I do know folks that are working on Owens Lake, but yeah, I can't really comment on the trends there myself.
Robin asked if we could get a link to the paper by Carl Zimmer, and if it's behind it's behind a paywall. We will over the next few days try to see if we can get an access to it that we can share with our members. So check our website, take the speaker page. We should be posting this recording on Wednesday next week, and we will have, if we can get it, we will post it there. Any last questions? I know we're kind of at the end of our allotted time. All right. Well, Nathan, thank you so much for speaking to our members. Everyone who's here, thank you so much for joining us tonight and for your support. We are so grateful for all of you and helping us in the monumental effort to protect birds. And I look forward to seeing you all next month. Good night, all.
Thanks for hosting me. Great talking to you all.